Okay, before we leave today, I want to, which one did we do? We're November something? Where's the program we did the other day? Do you remember what I called it?
It would have been on the 12th, wouldn't it?
November 12th.
Where is it? I know we just did. Okay, we're going to cover this more here in a minute, but I want to look at the slides real quick. Go to where we left off. We're not going to do too much more of it because I just don't really like the way they did it. And we were on, see if someone can help me figure out where we're at. Is it here?
Yeah.
It was right around here. So I think it was demo 2, wasn't it? Yeah, we hadn't got the polymorphism yet. We did that one. Yeah, here's, is that the one?
I already talked about it, but we went over it.
Find where we're at. Yeah, okay, here's where it had the error. That right here, this choices with parentheses, that was the error. And then I noticed that if you look over here, no, that's not the darn it. Here they had actually fixed it on 5 slides farther. So it would have been nice if they were consistent. It would have made our life a little bit easier. They talk about polymorphism a little bit, okay? And I put a comment in here. Let's talk about what polymorphism is. It says a feature of a programming language that allows routines to use variables of different types at different times. It basically gives you the ability to use different type variables, okay? It gives something the ability to change. It says methods are always determined by the type of the actual object and not by the type of the variable containing the object, okay? They can change based on when you call them. If you're calling a list or an object or a string, it can change based upon what type the variable is, okay? It's not critical you understand this at this point because I'm not going to make you use it. But just know that with Python in particular, it can change. A variable can change. You can actually use the same variable name for multiple types of variables, okay? So I could call something name. Name could contain a string. You all agree with that? Could name contain a list? Name could be a list. It could be a set. It could be an object. It could be anything. And it really can change based upon when it's called. Okay. So it's just not that big of a deal. They walk through this thing many, many, many times. Now, what he's really doing here is he's really just creating different programs. We've already discussed how most of it works. He's just walking through another example. I'm not going to walk through his example, but I'm not going to make you do it. But if you get a chance and you're interested in this, which there might be one of you or a couple of you, read through it. I mean, he does a decent job explaining, but what he's explaining is explaining what his program does. Okay? I'm just not going to walk through it with you. Okay? Sure. I think we'd be better off really walking through the other program we wrote the other day, because at the end of the day, quite a few of you were confused. Heck, I was even confused there for me because we couldn't figure out the darn parentheses. See, that's the problem using somebody else's code. You get it, and, you know, so many times you get stuff from other people and you don't understand. That's where comments come in handy. What does this code actually do? You know, I grade programs every week, and it never fails. Every single week I get stuff where you tell people just copy it off the internet. It's like it's not even doing what it's supposed to be doing, okay? So I want to walk through the program we wrote Monday very slowly so we can all understand everything, okay? Sound good? Because it is an important concept. Now, why did he call main initially? Remember why he said that? First of all the stuff above, that's where we define the class, we define the methods, we define the subclass and the superclass. Main is where the program starts. The reason he came up with main was because a lot of languages start with main. You know, Java starts with main. A lot of them start with main, so why not be consistent? So when we call main on line 47, what's it actually doing? Anybody?
It's starting the program.
It's starting it, but then where does it go? Where does the control go from that point?
To the defined main, the function main.
Correct. It goes to line 39. So it goes to the main method in my code on line 39. Okay? So we're not passing any arguments. Again, when you see parentheses with nothing inside of them, you're not passing any arguments to it. Okay? No parameters, nothing. So on line 39, that's where we define the method. Again, it does not receive any arguments. Could we provide arguments? Well, actually, I'm not going to get that one. Get that. Get that. Let's go to 40. What does line 40 do? Okay, what is first? Right here on line 40. What's first? On line 40.
First,
What is, don't look at that. What is first?
the variable first.
It's a variable. We declare a variable called first. Could we have called it peanut butter jelly? We could call it anything. It doesn't matter. It's just a variable. But we got to be consistent.
Well, we're setting first equal to choice
Right.
question, which is another function, correct?
It's actually a class in this
Class,
class. Right. So first is our variable. It doesn't matter what we call it, but you try to come up with names that mean something. Okay. This is the first question. Then in the example, you have the second question and stuff like that. Is first a great? Probably not. I probably said, you know, first Q or something, so I know it was the first question. But, so we declare it there, and every time from that point when we use it, you gotta spell it the same. I know some of you had an issue with like add choices, making a small c compared with a large c. So you gotta be consistent. So first is equal to choice question. At that point, it's calling the class choice question and assigning a reference to that class, or that object basically, in the first. So based upon this code, where does my code jump to next? Someone tell me where it goes to. I'm going to keep scrolling up until someone tells me to stop. Stop. Okay. So since first was assigned choice question, it's jumping to line 18. Okay. Now, does REPL have the ability to go line by line? It does, doesn't it? Does it do that? Does it have the, oh, it does have a debugger. So I'm going to try this real quick. I never tried it in here. We can see if it works. Click here to start the debugger. Got it. Step over, step into. Okay, let's go resume. Can't do that one. Well, I don't know if I can do this or not. Oh, it's right there. There's the arrow. Okay. So I'm starting the debugger. So it goes to line 1. Okay. So it goes to the declaration line. Let's go to the next one. That would be resume. This should go to where? Maybe not.
It ran the program.
Oh, it did. Oh, that's not what I wanted. Stop it again. Let's start all over.
I think you need to step down or step up.
Yeah, I don't know.
I think you need to go into it.
Okay, so it's going to each of these. There it goes. So after they've all been, wait a minute now. I wanted to start on line 47. Why didn't it?
I have no idea. I haven't played with it.
Yeah, you know what? I'm not going to work with the debugger anymore. I don't care about trying to figure it out at this point. Okay, so we jumped up here to choice question. Okay, then what is line 19? Anybody? What's line 19?
A constructor.
It's a constructor, exactly. It's a constructor. And remember, we need to specify self, okay? Now, this is 2 underscores and 2 underscores. Then the very next line is called super init. Anybody know what that does?
That's the calling the constructor from the superclass.
Right. It's calling the constructor from the superclass. So line 20 is calling the constructor we know by init, but it's not calling itself, it's calling the one from the superclass. And where the heck did that come from? If you go on up here, see, check this out. You see choice question? See how it's got an argument of question? That matches right here. Okay? So basically, on line 20, we're actually calling the constructor from the superclass question, which is right here. So go to line 2. Okay? Now, line 3 in that constructor is creating 2 variables. Now, are these instance variables or class variables? They're instance variables. How do you know they're instance variables?
They're inside the method,
They're inside the constructor. How can I make them class variables? Anybody?
outside.
So literally, if I made them at the same level as the define, they would become class variables. But since they're inside the constructor, text and answer are both being defined inside as instance variables. Now they're set to nothing. Okay. Are these public or private?
Those are public.
Public. How do I make them private? Double,
Exactly.
exactly. Okay. What was your question?
Would you always want to put your variables in the constructor?
Yes. You can declare them outside, but again, they become class at that point. You can, well, okay, to answer your question, if you don't need a variable in the constructor, you can define it later inside of a method, and it will still work as well. Normally, when you write code, you define your variables at the top, and this is basically the constructors we're going to define. So this does it a little bit different. See, like in Java, you define them at the top, not inside the constructor. And unless you define them static, they are instance variables. They have to be defined static to become class variables. That's where it's a little bit different than Java. But in Python, instances are inside the constructor. Okay, so basically text at this point is equal to nothing, answer is equal to nothing. So come back down to, where were we at? Right here. Okay. So this super again needs to be first. It doesn't have to be in Python, but it should. Then the next thing we do is this self.choice equals square brackets. What's that doing? Anybody?
It's an empty set.
That's creating a list.
It's creating a list.
The set is the.
It's creating a new, is this an instance variable or a class variable? It's an instance variable because we're defining inside the constructor. It's called choices with an underscore. It's public, even though the book says it's private, but, and it's going to be a list. The list is equal to nothing at this point. Okay.
It's not appended.
So now we come down here. So that's line 40. So now we go to 41. So now we're saying, okay, we have first, which is a reference to an object of type choice question. So now we're going to say, okay, that object we're calling first.setText. Well, when we declared choice question up here, it actually brought in the constructor, the add choices. In other words, it became aware of these different methods. So how the heck does it know about SetText? There's no SetText in here. You see a SetText between line 18 and 32 or no? So how does it know SetText? Anybody?
Because of the end, you're passing that.
Well, that's the argument, but where is the method SetText?
Some question.
It's in question. It's right here on line 6. So how does it know about that? Well, choice question inherited the functionality of question. Okay. Remember that right here where it talks about question right here, so it didn't hear it in this class? Right. So what happened is when we declared choice question, it brought in all the functionality of question. You know, and a lot of people ask me, why the heck would you ever want to write code like this? Because it's very easy to manage. Again, you guys are new at this. Most of you are. Right? But when you really start doing this for a living, you really start seeing the benefit of it. Okay? It's kind of like you really need to have a blueprint for a house. No, you really don't. Have you ever built something without instructions or without anything? and a lot of times it turns to junk because you did it wrong. Okay, so once you start playing with this and doing it the correct way, your code becomes so much more usable. Okay, because we have this question, and we also have this choice question. We can make another class called fill in the blank question or whatever type of question. And whenever class we add, automatically brings in all this functionality. So I can call SetText for whatever type of question I have. Why write the code twice?
So you can only pass one thing on it. You can't pass multiple.
You can pass multiple actually, but you can only return one object. So you can actually pass multiple things. But what we could do is we could have multiple classes and they can all inherit from question. Okay, I was going to assign this to you guys, but I figured you'd be a little confused since this was confusing. I make my students do a pizza class. We have pizza class. Well, first we have a driver to run it, which is kind of like our main. Then I have pizza class, then I have cheese class and meat class. Cheese and meat are both inherited from pizza. Y'all agree pizza would be like the super class, cheese and meat would be like the subclass, kind of like question and then choice question and fill in the blank question. So you inherit the functionality. We do not have to take SetText and write it again. It's already written. We can just use it. That's the beauty of inheritance. So when we called down here, when we called SetText on line 41, first.setText, it immediately knew about SetText on line 6. And it said, hey, text is equal to the question text, or whatever I pass it. In this case, was just the word in.
So where does it get question text from?
Okay. It got question text from right here. Okay? Because when we called it down here, when we called SetText, we passed it an argument. That argument becomes the question text. Okay? So that's received up here under question text. Now, self, remember that's something we always have to have. So that in, or that question text, gets received here, and that gets set into self._text.
Self makes it into that one instance, correct?
Right, that instance, correct. Basically what it's saying is self._text is an instance variable, but it was already defined here, so we know about it for the entire class. So I can use self_text here, I can use it here, I can use it anywhere. So I can use it to check my question if I wanted to. I can use it to display the question. Anywhere in this class it can be used.
So I guess my other question is, why wouldn't you just combine with classes to begin with? Why feed it into it?
Because choice question down here, let me scroll down a little bit. Choice question is working with a list. Remember a choice had multiple choice. But do all questions, are they multiple choice?
No.
No. So why would I combine those? Maybe I want a display method that's part of choice question, a different display method that's part of a fill in the blank question, and a different display method that's part of another question. So, and it's called overload. You can use the same method over and over and over. And I think we actually do. And it's actually right here. Line 15 has display, which means it pertains to the question object, the question class. Line 28, it's called display again. Since that in the same name with the same argument of self, this one overrides the main one.
Because of the SuperDisplay?
Right, because we're calling display in the other one, exactly. It's like, hey, we're bringing that, plus we're adding some additional functionality to it. Because what that does, so 29 says, okay, give me this one. So it takes that one, prints it, and then it goes ahead and prints the other options. So we print the question and then all the choices. So you can, you're using it, but adding to it. You're giving it just a little bit more functionality. Okay. So that's where SetText is. Now when we call first.add choices, we're passing in two arguments, 1991 and a true. So add choices. So again, first is a choice question. So I'm going to go check and see if add choice is inside of choice questions. And it sure is. There's my class choice question. And there on line 22 is my method or function, actually method in this case, add choices. Now, it received two things. It received a string and a Boolean variable. And when you work with Boolean in Python, it has to be a capital T or a capital F. So under add choices, the text of it appeared into the variable choice, and the Boolean appeared into correct.
Well, how come you don't have a scope error between the initialization and the add choices where you're trying to append into a different method? It seems like you get a scope error between add choices and the initialization.
Well, because this is defined inside the constructor, it's available in the entire class.
Okay.
Yeah. Anything you define, what he's talking about is if you define something local to a method, like if we did not define this choices here, but we defined it down here, you know, say we took this line and moved it in here, it's only available in here. But since we defined it in the constructor, it's available in all these methods that pertain to that class.
So you have two different constructors too. You have a super constructor.
Well, I have the super, which is in the super class, and this is the subclass, so this is really the subconstructor. But again, choice could also have other classes. I think he actually does it as an example. You could have multiple choice, you could have single choice, you could have multiple select even. You could even inherit this down even farther.
So this is kind of like the code for like how.
Canvas works.
Yeah, exactly.
Exactly the way it works.
That's how you set it equal to objective and subjective questions. Just a few lines.
And it's funny, I was working with D2L yesterday, and we've had an issue with D2L is the way the quizzes work and the way some of the stuff works. So that's why we're leaving it. OSU is leaving them. A lot of people are leaving them.
Yeah, everywhere I keep hearing it's going to Canvas.
And then the funny thing was, literally, I logged in yesterday to look at last semester's quiz. It's like, hey, we have all this new functionality available quizzes. We'd like to use it. I'm like, no. And then they're like, why not?
Yeah, why not?
Because we're leaving you, dude. We're out of here. Why would
You can't leave.
Well, I think they're finally realizing, crap,
We gotta go.
we're
We
losing
gotta
all
go.
of our customers. Okay, so add choices. It received choice. Again, choice is, in this case, 1991. And then it received correct, which in this case happens to be true. Okay. So then we took that and appended, we did underscore choices dot append, which is a method for a list. We said append choice. So what exactly did it append?
The date.
It depended the date 1991. Because 1991 was received as choice. So we appended 1991 to the list of choices at this point. Okay? So remember, choices was a list that had nothing in it. Because when we defined it right here, it was blank. So the first time we call this, we append something. In
That's
this case,
choice.
it's 90. What now?
That's choice, and the list is choices.
Same. Choices, choices.
Oh, okay.
Oh, choice is the text
Okay.
that you're adding. Just the best option for name probably. That's why I think we got confused. There was choice and choices. And okay.
Add choice.
Choices is a list of choice.
Okay.
Is. Okay. I know, it's fine.
Oh, that's what I get.
Yes. Okay. Then we got this if correct. Well, what is correct?
It would have to be from the bottom, wouldn't it?
Have to be from the bottom. So in the first case, it's true. So we receive true.
So that's basically if true.
Right. So this is saying, so correct is true. So if true, well, it is true. So we can continue on. So we say choice string is equal to the length of choices. In other words, how many variables are in there. What this is doing, because remember down here, if you look, so 1991 is true, so that is going to be the correct answer. 1995 is false, so that's going to be the false answer. So since this is set to true, up here when we said if true, in this case, then we set the choice string to the index number of the last answer we had.
Can you scroll back down? So I guess what I don't understand is how, when you just do first dot add choices, how does it add to choice and then add to correct? Why doesn't it add to just choices or just correct?
Okay. When we call add choices,
Uh-huh.
it calls this method right here.
Yeah.
Okay. So it comes in here, receives these two arguments, so it appends the choices. So it added 1991.
Yep.
Okay, we got that. Then the very next line on line 24 says if correct.
Is true.
If it's true, so if it was true, then what we do here is we check the length of the list. In this case, it's only one. So we're finding out what we just added. Because remember, when you add a list, you append to it, you're adding on one more option under it. So since it's true on line 24,
Is the list.
we're finding out the length of the list. So in this case, it's going to be 1, since it's the first one we're adding. So if true, so we're taking it and we're adding, so the number 1, in other words, the length of the list, in this case is 1, converted to a string is just stored there. So choice string is going to contain 1, just 1. Now we're going to set the answer to what? 1. So set answer is going to be set to 1. Now we know what the correct answer is. But where the heck is set answer at? Everybody see set answer?
It would have to be up top, wouldn't it?
It's up top, right here. Set answer is
Correct.
the correct response. And in this case, it would be 1. So 1 is the correct response. In other words, the first entry in the list is correct. Okay? So we set answer to 1. Okay. Now, that's what we did on the first one. Now let's get the second one. We call add choices again. So remember, choices at this point contains one entry, 1991. That's it. So we call add choices again. So add choices, we're back up to line 22. We receive 1995 and false. So we take our list, we append 1995. So now how many entries are on our list? Now we got 2. 1991 is first, 1992 is second. So we appended it. Correct is now false. Remember, we passed it a false down here. We passed it false.
So that if statement changes to if false now.
If false, and it's not false. I mean, remember, if it's true, it does the if statement.
If it's
But it's not true, it's false, so we don't do the if statement. So we do not set the correct answer to number 2. We basically skip this. 24, 25, 6, we don't do nothing to it. Because that's false. If false, done. We don't do it. Now, if there was an else statement, maybe we could do something else. So basically, we do not change the set answer.
Interesting.
At that point, it's all set. We set the true, we set the false. Then when he says present question, let's find present question. It's right here. Now we're passing it first. What is first again?
Choice question.
First is our first question, which is actually a reference to the object. It's really pointing to a new choice question. This case, it is our first question. So first is received as Q. IQ, probably for question. Then we call display. So what we do is we go up here and we look. Do we have a display? Ah, sure do, right there. So we have a display method. So what does display do? Display calls display. So we cruise on, it calls SuperDisplay. So that means it's calling it from the superclass, and in this case, is on line 15. So what is 16 doing? It's printing out the actual question. And then, so we just did that. Oh, I'm sorry, right here. So we just displayed the question. Now, remember, this display is actually adding more functionality to the display above. Remember, the display above just prints the question. Just that one line of text. So this display here is now saying, hey, it's got a for loop. The range is up to the length of the list. How many is in a list at this point? 2. So it says, for I in range the length of the list, choice number is equal to I plus 1. Okay, so our list has two elements in it, 0 and 1. So choice number is set to I, which is initially what? 0. Remember, the list has 0 and 1 in it. And our range right here, remember, for I in range, the length of the list. So since we passed it 2, it's got 0 and 1 in it. Okay. So we get I, which is 0. 0 plus 1 is 1. So we print out a decimal and a string. The decimal we're printing out is choice number. In this case, it's 1. Then we print out a colon. Then we print out the first element in our choices list. So it's going to print out 1 colon and then the text of the first element in our list. In this case, it would be 1991. Then we go back up here, then I becomes 1. So then we print choice number becomes 1 plus 1, which is 2. So we print out 2 colon and then 1995. And that gives us our question.
So you're using choices right there as a list.
Yes.
But with the polymorphism, if we called that choices again, we could use that as a true false.
We
or
could use it,
numeric.
yes.
You don't have to redefine
Correct.
that particular one from the constructor.
Correct. Correct.
Okay.
We could use that again. Now, I'm just going to run this real quick. So it came up here, and it basically printed out my question. Now, my question to you is, where did we get this your answer from? I know. Well, remember when we called present question? Right here, we called this, which called this. It called display, which printed out just the in, which I probably should change. Then display, remember it printed out the in, and then to print this code right here, printed out our 2 choices. So that's what that all did. Then we get response for input. That's what it's waiting on right now. It's saying your answer, question mark, basically. And then it checks, it says print q.check answer. Okay. What is Q?
Question.
Q is a question. Remember, Q was actually first, and first is the question. So we need to find out what the heck check question does. Check question is not a part of choice question anyway. Okay? But since we inherited from question, check answer is right here. So what did we just pass to it? We just passed our response. So in this case, I'll say I put in the number 1. Okay, I haven't done it yet. But just say I enter 1. 1 will go into response. And we'll pass 1 up to check answer. So under check answer, that 1 will be received right here. Okay. Now, rather than printing, what it's doing is returning. It's returning 1. And now we have 2 equal signs. What's 2 equal signs?
Comparison.
It's a comparison or relational operator. It's basically saying, does 1 equal the answer? Well, does it? Well, yeah, because remember down here we had this thing here, if correct. Remember we set the correct answer to 1. So if I hit 1, this is true. Now let's try it again if I say 2. 2 is false. What if I reorder these? What if I go down here and make this one false? True. Now I run it. So now I say 1, false. False. Now let's run it again. And if I say 2, works perfectly. Okay. What if I want a third option? Could I add a third option? Let's see, 1996. False. So I added a line at line 44. You'll notice that instantly it's in my program. Okay? I didn't have to create a new method to add it to the list. I literally just called add choice. It automatically added it to my list, automatically did not set the correct answer to it because it's false. So now over here, if I hit 3, this is the beauty of object-oriented programming. I can add choices so easily. But here's my question. What happened if I say true here? What's the correct answer now?
Both of them.
Are you sure? Is it both of them, or I think 3 will be the only correct answer. Let's find out.
Who's the last
Try 1. 1's false, obviously. Let's try 2. Doesn't say true, say true. Doesn't 2 say true? So why the heck is it false?
Because the last one to be added was 1996.
Right. This is a multiple choice question, only supports one answer. So the last true it finds is set to the true, set to the correct answer. Because back up here, remember we did this if correct? It's not saying add it to the correct, it's basically saying replace it. Because if you look at set answer right here, it's taking that correct response, which in this case would be number 3 since it was the last one. It sets it to the answer, replacing whatever its current value was. So when I added number 2, 2 became the correct answer. But the moment I added 3, 3 overwrote the correct answer. Now what would happen if I did false here? And here.
And then there wouldn't be a true there.
Okay, let's try 1. False. Let's try 2. False. Let's try 3. There's no correct answer. What happens if I do 4? There's no answer. I mean, there's no right answer. Okay. Everybody see how that's working? Could I add a second question? Try it. Could I take this code right here? Rename it to second. Just make it 2. Make it 2. No, it doesn't count. And we'll say, change these so we know something different. This one true. All right.
Do you need to change that to second as well?
Yep, yes I do. Ah. All right, so here's our first question. My first question, the answer is 2. False. Instantly goes right into my next question.
That's how tests work.
And I'm gonna pick low. Yay. You know what? I don't like the way that looks. I don't like that colon after the number 1. I want to change it to a period. Can I do that?
And
But I mean, I got 6 lines there. 6 lines I need to change that colon to a period.
there's only really one spot you have to do that at.
Exactly. I got to do it in one spot right there.
I actually do think that looks better.
But see how easy it was? I was able to change all 6 lines of code by changing it in one spot. If we did not do it this way, I would have had to change it potentially in 6 places, which is amazing. Okay. Now, I don't like this false and then the question right after it. Actually, let me change my question anyway. Second question. First question. Okay. So now when I run it, looks a little better. How could I change it so there's like a blank line after it prints that false?
Line break
I could, where would I do that though?
in the same spot as you were earlier, your format statement.
So I can do it right here?
I believe.
Not here. What's this part doing? That's printing out the choices, the 1, 2, 3, and all that. Where is it printing out
Oh,
this
would it
false
need to
or
be-
true?
Print statement.
Where is it printing true or false? Anybody?
It would have to be.
Remember up here? Check answer returns true or false. So down here, when we call present question, right here, we're printing out that true or false. What if we just did, and since that's a Boolean, what if we just did this? That do it? Let's see. Ah. They were so easy. It was so easy to fix, and it pertains to everything. So we don't have to sit there and write multiple lines of code. We added it in one spot. So
Because
it's,
of the function.
yeah, because of the function call, and it would work for all questions that were inherited by this. Okay. What if I didn't want it to say true or false? What if I wanted to say right or wrong? How can I do that? Anybody? I want to say you are right, you are wrong. Where do I do that? Someone's got to have an idea.
Or the false.
The false is a Boolean statement, so you can't necessarily change it up. Unless those are also Boolean statements.
What's this doing right here?
So you could do if check answer is equal to false, then print something. Or
He's on the right track. What if I did if q.checkAnswer
Equals true.
technically I don't even have to say that. If check answer, so in other words, if it's true, print else
Print incorrect. Or wrong answer.
wrong. That do it? Let's try it.
Lose your,
Okay. Wrong. Oh, I lost my end, though, didn't I?
that's a mistake.
Fine, we're gonna fix it. Since this is a string, I can literally just put it right there. So let's run it again. So number 2 there, it's wrong. Hey, it's so easy to make a change. We were able to affect both questions just by changing it in one area. So we didn't have to manipulate the entire rest of the program. We literally just had to make a change. And that's, majority of time spent on programming is in maintenance. This was a maintenance fix, basically. Our requirements, after we were already done, says, you know what? I don't like true and false. I want right and wrong. So did we have to worry about how we added the parts to the question? No. All we had to do is look and see where we output the results and change this line of code to this. Now, I will tell you, in the real world, I commented that line out. Would I do that? Would I delete it?
You'd probably delete it.
What do you think, William? What do you? You've done programming.
I mean, it kind of depends on whether you're working with a team or not. If it's my code, I usually leave that stuff up because I don't like having to go back and forth. I mean, depending on where you go, it's going to be different based on the
If it's
style.
public or private.
See, it really depends. Now, when I worked in the military, we never deleted code. The reason is, I mean, when you're working on, a million-line program, are you positively sure this won't affect anything?
That's true.
Well, in this case, it doesn't. We know. But you're never totally sure. So you comment it out, and you would normally make a comment. This code was replaced with this code or something. You would put a comment in there about what we did. Initially, this printed true or false. This has been modified to print correct or wrong. And you leave that in there. Now, when you turn it in for me, delete it. Okay? But in the real world, you like the history of it. You like to be able to go back and say, what was it before? When I was in Tulsa working on my compiler project, I was getting so close to the end. I was literally making hourly backups. Every hour, I would upload the entire thing offsite. And there was a couple of times where I screwed stuff up. And I had to revert back a couple editions ago, which is nice. GitHub supports that, where you can go back and see You know, even Google Drive. Did y'all know that if you save a document in Google Drive, you can go back renditions of it?
No, I did not know.
You can do that. You right-click on it, you can see prior version. It'll, if you go in details, it'll literally tell you, you changed this word on line 52. And you can basically say, get that out of there. So it's very nice.
Does that apply to Google Docs and whatnot?
Yes,
as
it
well?
does. Very nice. So leaving that in there in production is a great idea because, yeah, we know we just fixed our problem, but what, you know, what if someone says, you know, I liked it better, true and false. I can just get rid of that, just uncomment that. We're back to, you know, we're back to business. We don't have to sit, you know, because how long did it take them to write that line? Not long, but what if it was a large function we were commenting out? We don't want to delete that whole function, just comment out that function. So that's how it's normally done. Okay. So very easy to add more questions. We literally could just copy this one little section of code there and add a third and a fourth and a fifth, and we can have as many questions as we want. So we understand that a little bit better today than we did Monday, I hope. Okay. All right, I'm not
I
going to make you
understand why you did all the work to make all these. Because it makes it so much easier to edit later. But
It is. It's so, I mean, when you initially make it, it's tough. But when you want to make changes later, it's so easy. Because the whole point of object-oriented is you can write it in pieces. You can write objects in little bit, and you can work on those specific pieces. Okay? So, kind of nice. All right. Well, I think that's all I'm going to cover today. You don't need to turn in anything today. Finish the program for next week. Again, I will have your stuff graded before I leave Saturday morning at 5 a.m. I probably won't do much over the holiday. I'll probably take an email, but I don't know how much I'm going to actually do. Okay. All right.
So you'll never make anything to do that.
Yes, ma'am.